Hello students, we have already discussed Mendeleev's periodic table and modern periodic table. We have seen its features which are structural features, its periods and groups. We have seen here it has 7 vertical horizontal rows, they are called periods, and it has 18 vertical rows, they are called groups. And today we are going to discuss 3 important features of the long form of periodic table. These are: first is this periodic table is in accordance with electronic configuration, and electronic configuration is a cause of periodicity. So it has given us as cause of periodicity. Second is important feature is relation between number of elements in a periodic table and number of electrons required. In how much electrons, how many electrons are required to fill all orbitals of a shell completely, and the number of elements in a period of this model periodic table. So there is this number of electrons is equal to number of these elements in this in a particular period. So this relation is also a specific or important feature of this periodic table. Then the third one is there is division of periodic table into S, P, and D and F block elements. The properties of S, P, and D and F are different, and they are placed in different portions of this periodic table, and that's a special feature of this periodic table. Let us discuss first repetition of properties. What is this accordance? What is this cause of periodicity? Manley failed to give this. He said that these elements are the elements with similar properties are repeated after regular intervals when they are arranged in the increasing order of atomic masses. But he did not give the reason why they resemble each other. But in the modern periodic table, mostly said that when we arrange them in increasing order of atomic numbers, the atom elements with similar properties are repeated after regular intervals. Here, when we see these, when we arrange them up in regular interval, and this repetition is called periodicity. We see that the elements of a periodic group, for example, we are here. Here we have one group. This is, we call them 1, 2, 3, 4. First is called alkali metals. These are alkaline earth metals. Then we have transition elements. Okay. When we see, for example, let us take the alkali metals here. Alkali metals: lithium, sodium, potassium, rubidium. Then we have cesium and francium. I have taken these 4. You see, the atomic number of lithium is 3, and it is electron configuration 1s2, 2s1. Sodium has 11, 1s2, 2s2, 2p6, 3s1. Potassium, its atomic number is 19, 1s2, 2s2, 2p6, 3s2, 3p6, 4s. You see that all these have to have s1 configuration, ns1. It means that the valence shell has 1 electron in s subshell, in s orbital of s subshell. And this basically, this resemblance in the valence shell electron configuration is basically the cause of period. This is basically which determines the properties of the elements. You know that an atom has a nucleus, it has then electrons. Nucleus contains these protons and neutrons, and these extra nuclear pod contains shells which contain these these electrons. But we know that only the valence shell electrons take part in the bond formation. So here, when we have the same valence shell electronic configuration, this same electronic configuration reflects their properties, shows that this determines that they have similar properties. So you can see halogens. We have fluorine, chlorine, bromine. You can see we have 2p, 3p5, 2p5, 3p5, and 4p5 problem in this configuration, and this determines their properties. So this important feature of the long form periodic table is that it shows us, gives us the cause of periodicity, and it says that it is this repetition of the valence shell electron configuration which repeats the properties of the element. So this is one. Second is relation between number of elements of periodic table and the number of in the periodic table and number of electrons in the shell. We see that each period begins with the filling of electrons in the orbit. It means that when we start here, first shell is completed, and here second shell is completed, and here a third shell starts from this alkali metal, and it is slowly and steadily filled up to this and completed here in this inert gas, noble gas. Okay, here we can see that the first shell first shell of this period of every atom contains only one subshell, S subshell, and S subshell contains only one orbital, and one orbital can accommodate two electrons. So two electrons are required to fill first subshell, and we know that the first this period of the periodic table contains only two elements. Configuration is 1s2, 1s1, and 1s2. Similarly, when we go to second shell, it has two subshells, S and P. S has one orbital, S orbital, and P has three orbitals. In all, there are four orbitals. Four orbitals can accommodate 8 electrons. So the second shell contains 8 elements. First here, one electron goes to this second shell, then it goes second electron, third electron, 4, 5, 6, and 8, and this is completed. Then let us go to the third shell. Third shell contains three subshells, S, P, D. But we know that the 3D is filled up to 4s, since its energy as per N plus L rule is more than 4s. So it is filled in with 4 shell. So here only we have two shells, S and P are filled. And thus we have four orbitals which can accommodate 8 electrons. So this third period also of the periodic table also contains 8 elements. Here we have, these are from sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. So here also we have, it coincides with the number of electrons in the orbitals of the atom of the third shell. Okay, then we have fourth shell. We can see that fourth shell has SPD. This is 4s, 4p, 4d. Okay, but we know that the 4d is filled up to 5s because it is as per N plus L rule, its energy is higher than 5s, so it is filled with 5 shell. But we have 3d vacant yet, which is filled up to 4s. So we have here three subshells. We have 4s, 4p, and 3d, and in all we have 4 and 5 is 9 orbitals. 9 orbitals can accommodate 18 electrons. So here we have 18 elements. It starts from this potassium, then we have calcium, then we have these transition elements, then we have aluminum, silicon, phosphorus, sulfur, chlorine, argon. So we have 18. Similarly, when we go down this, when we go down, we see that the number of electrons required to fill all orbitals of the shell is equal to the number of elements in the particular period of the periodic table. So it coincides with the number of electrons required to fill different orbitals of the shell.